Hello everyone and welcome back to the tutorial series. In this part of the tutorial, we will be cross-compiling and packaging a Linux Unreal Engine server from our Windows machine so that we can upload a Linux game server build to GameLift and create a fleet with that Linux server build. Throughout this tutorial series up until now, we have always packaged our game server as a Windows server build, which works absolutely fine, but the reason that we are going over cross-compilation in Unreal Engine for Linux is that Linux EC2 instances on AWS are generally cheaper than Windows EC2 instances on AWS. So you can save a lot of money creating fleets with Linux instances instead of fleets with Windows instances. Keep in mind though that the process for setting up a Linux game server build for GameLift will be slightly different than that for setting up a Windows game server build for GameLift. Also, unlike the last part of the tutorial when we remotely connected to a Windows EC2 instance, there won't be a nice graphical user interface when we remotely connect into a Linux EC2 instance. But we will be going over how to go about all of this in this video, and right before we begin, special thanks to our patrons on Patreon as well as anyone who has donated to us. We really appreciate the support. With all of that said, let's get started. Now, the very first thing that we are going to do is enable the Windows Subsystem for Linux feature, because Windows Subsystem for Linux is essentially a compatibility layer for running Linux binary executables on Windows 10. So this feature will enable you to run native Linux command line tools, utilities, and applications in the GNU/Linux environment of your choice on Windows without the overhead of a virtual machine or dual boot setup. Now, keep in mind that I did just say Windows 10, so this part of the tutorial will not work for you if you are using versions of Windows older than Windows 10. Also, keep in mind that since we are using a compatibility layer rather than a virtual machine or dual boot, the Windows Subsystem for Linux version 1 at least, which is the version that we will be using in this tutorial, is not running a Linux kernel or an operating system. Therefore, what we are using in this tutorial cannot replace Linux completely. It's just a simple lightweight interface that translates system calls for a GNU/Linux distribution into system calls for Windows, which means it's geared towards Windows developers who want to run bash shell scripts and core Linux commands, not necessarily to run graphical Linux desktop applications, for example. For those who are familiar with the Wine software on Linux, the Windows Subsystem for Linux is similar to that. Note that everything I just said applies to version 1 of the Windows Subsystem for Linux. I understand that the second version is much different, and we will briefly touch upon that later in this video. But for now, let's just enable this feature. So go down to the search bar in the bottom left corner and look up Turn Windows Features On or Off and select the best match result. And that should open up this window titled Windows Features. And scroll down and find the feature named Windows Subsystem for Linux and make sure that there is a check mark in the box to the left of it so that the feature is enabled. Now, if you can't find the feature named Windows Subsystem for Linux in this list, which is usually only the case if you have a very old version of Windows 10, then you may have to enable this feature through a command in PowerShell ran in administrator mode, and I will have a link to a documentation article that contains that command. Again, that is only the case if you don't see the Windows Subsystem for Linux feature in this Windows feature window like I see now. Moving on, once that feature is enabled, let's apply this change by clicking the OK button. And if you didn't have this feature enabled before and had to enable it now, then you're going to have to briefly wait for Windows to enable the feature. And once it's done, you will be prompted to restart your computer. So once you've reached this screen, just go ahead and click on the Restart Now button. And that should have restarted your computer. Once your computer is finished restarting, let's install a Linux environment for the Windows Subsystem for Linux from the Microsoft Store. So let's open up the Microsoft Store, go back to the search bar and type Microsoft Store and select the best match result. Now, the specific Linux distribution that we are going to install for this tutorial will be Ubuntu. So in the top right corner of the store, click on the search button, and then inside this text box, just click inside here and start typing out Ubuntu and then press enter. And then from these app results, you actually have to install Ubuntu 18.04 LTS, because I actually had to go back and re-record this clip after realizing that the newer version of Ubuntu will not work for this tutorial. That includes both this first plain Ubuntu option and the one to the right of it called Ubuntu 20.04 LTS. At the time of filming this video, if you have installed the plain Ubuntu option, then it's basically exactly the same as installing Ubuntu 20.04 LTS, and you actually have to get the older version of Ubuntu for the rest of this video to work. So click on Ubuntu 18.04 LTS, ignore the fact that it says the word owned underneath it. It may say free for you instead, and after I click on this, it may not say that you own this app either, and this install button to the right may say get, since for many of you guys watching this may be the first time that you are installing Ubuntu 18.04 LTS. If that is the case, click on the get button where my mouse is, or around where my mouse button is, and once you click on the get button, it should become an install button in around the same spot. Click on that install button to install the complete Ubuntu terminal environment. And after Ubuntu is finished installing, go ahead and click the launch button to run the Ubuntu terminal. Note the first time you run the Ubuntu terminal, you may have to wait a little bit for some further installation to finish. And since I had to go back and refilm this clip as well, I wanted to quickly point out that from this point on in the video, you may see Ubuntu version 20.04 being used, or when I go to look up Ubuntu in my search bar, you may not see Ubuntu 18.04 LTS like you see now, but you may see just plain Ubuntu instead without the 18.04 LTS. Also, when I'm running, when I'm running different commands later on in this video in the Ubuntu terminal, the lines printed out may not look exactly the same as the ones you see when those same commands are ran on your Ubuntu terminal. Please try your best to ignore all of that, because when I originally filmed this tutorial, I was using Ubuntu version 20.04, which is the default version of the plain Ubuntu option in the Microsoft Store. The problem is that the latest tools for the newer version of Ubuntu cause the library file that has to be built for the GameLift server SDK to be dependent on files that are too new for the Amazon Linux EC2 instance, which runs on a very old operating system. I believe the operating system dates back to 2012. With that said, the exact same steps that I ran before on the newer version of Ubuntu will work on the older version of Ubuntu. It's just that in this weird scenario, you have to run these steps, at least for building the GameLift server SDK Linux binary file, on the older version of Ubuntu, which in this case is going to be 18.04. Thank you guys for understanding. Let's get back to the video. Once the Ubuntu terminal has finished installing, you will be prompted to create an account, but first I'm going to expand the terminal window so that you guys can see better. Now you will be prompted to create a default Unix user account, which will consist of a username and password. So starting with the username, you can literally make it anything. So I'm going to make it Chris, and then once you are done with your username, press enter. And for the password, again, you can literally make it anything. So type out a password, press enter, and then retype that same password to confirm your password, and then press enter again, and then that is it. You can now start running Linux command from this terminal. Note that you should remember the password you used when making that account you just made, because that password will be needed for whenever you run a sudo command for the first time right after opening up a new Ubuntu terminal instance. And the sudo keyword is used at the beginning of a command to give a user permission to run that command at the root or super user level. But anyways, let's just run some commands to make sure that everything is working. So first, let's type clear and press enter to clear the terminal. And then let's do echo, and then in quotes, we love Flopperam. And if we press enter, we should see on the next line exactly the phrase that we put in quotes. And everything looks as though it is working as intended, but before we move on to the next step for building a Linux game server for GameLift, I just want to quickly open up command prompt and run the command wsl-l-v, because this command will list out all of the Linux distributions we currently have and what version of Windows Subsystem for Linux that they are running on. Currently we have Ubuntu on version 1, since that should be the default. Like I mentioned earlier, there is a version 2 of WSL. There are huge differences between version 1 and version 2. Version 1 is just a compatibility layer, while version 2 has an actual Linux kernel running in a virtual environment managed by a hypervisor. Basically, version 2 has way more features than version 1, but for our purposes in this tutorial, which include building some files, creating bash shell scripts, and uploading server builds to GameLift, version 1 is more than enough, so we will stick to that for this tutorial. But if you are interested in upgrading to WSL version 2, we will have a link to an article that shows how to do so in the description below. But moving on, let's close out of this command prompt and let's go ahead and build the C++ server SDK library file for the GameLift server SDK plugin. Now, all the way back in part 2 of the tutorial series, we built these SDK library files for Windows server builds. So the binary files generated were in the form of DLL and lib files. This time we are going to build these SDK library files for Linux server builds. So the result will be one binary file in the form of an SO file. So I'm just going to pull up File Explorer, specifically in the Downloads folder, because in part 2 of the tutorial series, we did download the GameLift server SDK from the GameLift Getting Started website. We extracted the files, made sure that the output folder name wasn't too long, and dragged the C++ server SDK and Unreal plugin folders out of the main SDK directory into the downloads folder to avoid really long directory paths. Luckily, I never got rid of any of those GameLift folders from part 2. Now, it has been a very long time since part 2 was uploaded, so I would imagine that many of you have deleted these GameLift directories. If so, not a problem. Fortunately, the GameLift server SDK has not been updated since then, so if you have to re-download the GameLift server SDK in order to rebuild the C++ server SDK library files, then go back to part 2 of the tutorial series and rewatch from 5 minutes and 15 seconds to 7 minutes and 30 seconds. Link to that video will be in the description below. And if you surprisingly were like me and actually kept the original GameLift CPP server SDK folder where you built the Windows server SDK binary files, that is fine too. We can still use that directory. We're just going to have to run an extra command to delete the out folder from previously, which we will get to when we get there. Now, keep in mind that if you did have to re-download, extract, and move various folders in the GameLift server SDK, then I would highly advise restarting the Ubuntu terminal. In fact, let's just do it anyway. So I'm going to close out of this and then reopen it by looking up Ubuntu and selecting the best match result. Now, when we built the C++ server SDK libraries for Windows, we ran the Cmake command, and we have to run the Cmake command again to build the libraries for Linux, but we actually have to install Cmake again for this Ubuntu Linux environment. Before we do that, we need to ensure that whenever we install libraries or packages in Ubuntu, we get the latest libraries or packages. So type out sudo apt update, press enter, and you will be prompted to type in your password. So hopefully you remembered it, type it in, press enter again. Now, this update command doesn't install anything, it just updates your system's package index files so that when you actually install new software, the locations from where you install that software from are up to date and new. Once sudo apt update has finished, you will notice that there are 11 packages that can be upgraded. So if you actually wanted to install new versions of packages already installed, you can run the command sudo apt upgrade, and it'll prompt you, do you want to continue? Just click or just type in Y, case insensitive. And if you are serious about using Windows Subsystem for Linux later on beyond this tutorial, then I would suggest routinely running the sudo apt update and upgrade commands in order to make sure that you have the latest packages installed. Once both our current packages and the information in our package lists gathered from various repositories and archives used for installing new packages is up to date, let's run the clear command to clear out the terminal so that we can again better see what's going on. We also still need to install Cmake for Linux, so write out sudo apt install Cmake and press enter. And you're going to be prompted with, do you want to continue? Just type out Y, case insensitive, press enter again. And once Cmake has finished installing, let's run the clear command again to clear up the terminal. Like I mentioned earlier in this part of the tutorial, we cannot use Ubuntu version 20.04, which is why we had to settle with Ubuntu version 18.04. Because if I run cmake --version, gcc --version, and make --version, you will see the version of each one of these tools that was just installed when we installed Cmake and its dependencies. All of these versions are not the actual latest versions of these utilities, but they are the latest versions for Ubuntu 18.04 according to the Debian Advanced Package tool at the time of filming this video, and these versions of these tools will work. Newer versions of these same utilities that get installed when you install them on Ubuntu 20.04 will not work, so make sure that the versions of Cmake, GCC, and Make are similar to that of mine. I will clear out of this so that we can move on. Now we also need to install the build essential package because it contains so many common packages such as the GCC compiler and others needed to compile software in Debian, which is the GNU/Linux distribution that Ubuntu is built on top of. So let's install this by typing sudo apt install build-essential and press enter. And then for your password, again, just type it out when it prompts you for your password, and then it's also going to prompt you, do you want to continue? Just type out Y case insensitive and press enter once again. And once the build essential package is finished installing, we should have everything we need to build this library file for the GameLift server SDK. So go back to File Explorer, specifically in your downloads folder or wherever you downloaded and extracted the GameLift server SDK, and move the GameLift CPP server SDK folder to. Double click the GameLift CPP server SDK folder and then copy the path from File Explorer. Go back to the Ubuntu terminal. First, let's clear the terminal once again, and then before we cd into the GameLift CPP server SDK directory so that we can generate this SO binary file, we have to convert the Windows path into a Linux path, because you will see that the paths of directories and files look a little different in the Ubuntu terminal. So to convert the path, we have to run the wslpath command. So type out wslpath space and then in quotes paste the path of the CPP server SDK directory that we just copied by clicking the right mouse button, since Ctrl-Shift-V won't work unless you enable it in the Ubuntu settings, which if you prefer, we will have a link in the description below on how you can enable that. But for now, just go ahead and press enter. After executing that command, you will notice that the Linux readable path looks different than the original path that we copied from File Explorer. The backslashes were replaced with forward slashes, and the C drive is now noted as /mnt/c/ instead of c:/. Moving on, let's cd into this directory because this directory contains all the Cmake files that we need to execute. So type cd space and then highlight the new path generated from the wslpath command by holding your mouse down on one end of the path and bringing the mouse as horizontally as you can to the other end. Press Ctrl-C and then to copy it, and then click on the right mouse button to paste the path and then press enter. Now that we are cd'd into the GameLift CPP server SDK folder, let's first remove the existing out directory inside here if one exists. Now if you had to re-download the GameLift server SDK, then you probably don't have to run this command, but for me, since I'm using the same GameLift SDK folder where I built the library files for Windows server builds, I'm going to remove the existing out directory by typing rm -rf -out and press enter. For those who are curious, the rm command stands for remove, and then the -rf flag just means recursively delete everything in the directory. And don't prompt me about whether or not I'm sure I want to delete specific files. You have my permission to delete everything. Once the out directory is removed, let's remake it because we still need a new folder to hold all of the output files generated from running the cmake and make command. So let's type out mkdir because that's the command to make a new directory, and we are going to name it the same thing as before, out. So type out out and press enter, and of course let's cd into that new directory by typing cd out and press enter again. And the first thing we are going to do while cd'd into this output folder is run the cmake command. So type out sudo because we actually have to run this command with admin privileges, so the cmake command without sudo privileges will not work in this case. Then type cmake and we're going to pass a couple of parameters. The first one is going to be -dbuild_4_unreal in all caps, source, and we are going to set that equal to 1. And the second parameter is going to be the path of the source code directory, which is one folder back, so write space, ... and then press enter. And it's going to prompt you for your password. Just go ahead and type it out and press enter again. And once Cmake is done, we can finish building the library files by running the make command, which we will also need to run with admin privileges, otherwise it won't work. So simply type out sudo make and press enter. Now it will take a while, but once the make command has finished and if it all went well, go back to the GameLift CPP server SDK directory in File Explorer and open up the out folder, then the prefix folder, then the lib folder. And you should see a file called libaws-cpp-sdk-gamelift-server.so. And if it is there, then we have to add this binary file to the Unreal Engine GameLift Server SDK plugin in our project. So open up another instance of File Explorer, specifically open at the location of the project and go to the plugins folder. Open up the GameLift Server SDK folder, open up the third-party folder, open up the GameLift Server SDK folder, and then open up the Linux folder, and finally open up the x86-64 unknown Linux GNU folder. And copy the lib aws-cpp-sdk-gamelift-server.so file from the GameLift CPP server SDK output directory and paste that file into this folder in the GameLift server SDK plugin directory. Just to briefly interrupt the tutorial, since we know that many people struggle with building the library file for the GameLift server SDK, if at any point in time you face issues while building the libaws-cpp-sdk-gamelift-server.so file, that SO file will be in this tutorial project's GitHub repository. Link to that is in the description below, so you can always grab the file from there if you think that you're spending too much time on this step. But of course, I always highly encourage you guys watching to spend at least some time trying to figure out why you are unable to build the binary file first before giving up. Now back to the tutorial. Now at this point, the project should be ready to be built and packaged as a Linux server. However, we still need to add the feature to Unreal Engine for cross-compiling for Linux from Windows. So to do that, go to this cross-compiling for Linux article in the Unreal Engine documentation. Link to this will be in the description below. By the way, just want to quickly note that if you are wondering why my web browser is suddenly darker than in previous videos in this tutorial series, the reason is that most of the viewers seem to prefer dark mode, so I'm going to try to use dark mode as much as I can in future tutorials moving forward. That includes IDEs, text editors, and other applications too. But moving on, once you are here, scroll down to the section labeled Getting the Toolchain, which will have a list of Clang-based Linux toolchains used for cross-compilation in Unreal Engine. Find the appropriate one for your Unreal Engine version. In this tutorial series, I used Unreal Engine version 4.24, so I'm going to click on where it says Clang 8.0.1 based in the toolchain column, and that should start the download for the toolchain installer. Once the download is finished, launch the executable that was downloaded, and that should prompt you do you want to allow this app to make changes to your device? Just go ahead and select yes. And then after clicking that should open up this window that you see on my screen right now. From here, just click on next and then click on install, and that'll start the installation of the Unreal Linux toolchain. Once the toolchain has finished installing, go ahead and click close to quit out of the installer. Now go to your project location in File Explorer and open up your project in Visual Studio. And once your project has opened up in Visual Studio, you will know if the Unreal Linux toolchain installation succeeded if, when you select the solution platform drop-down menu up here, you now see an option for Linux. So if you do see that option, go ahead and select that, because we are about to compile our project for the Linux platform. Now, if you don't see a Linux option, then you most likely have an older version of Unreal Engine, meaning that you may have to rerun the setup and generate project files batch scripts that we ran in part 1 of the tutorial series when we first built the engine from source in order for the toolchain to be linked with Unreal Engine. And if your version of Unreal Engine is really old, then you may have to also set an environment variable, which we will have more information about in the description below. But if you have the Linux option, then we can proceed with building a Linux server. And before we build Since we want to cross-compile for a Linux server, let's select the Solution Configuration drop-down menu to the left and make sure we have Development Server selected. Then go ahead and right-click our project in the Solution Explorer and select Build. And I forgot to warn you guys that the first time you build for any specific combination of a configuration and a platform with a specific instance of Unreal Engine, it will take a while. In this case, it was the development server build for the Linux platform. Just like how it took a long time the first time we built for the development editor and development server configurations for the Win64 platform, subsequent builds for these configuration and platform combinations will not take as long unless you are rebuilding the engine for whatever reason. May it be you just want to do that, or you modified the engine source code. And I could be wrong, but I believe the same logic applies to packaging as well. With that said, hopefully the project compiles successfully as a Linux server. Again, if it doesn't, then you may have to do more steps like I mentioned earlier in the case that you have a very old version of Unreal Engine, or you may have to double check that the version of the Linux toolchain that you installed was the right one for your version of Unreal Engine. Now let's build our project again for the development editor configuration for the Win64 platform so that we can make sure that we can open up our project in the Unreal Engine editor in order to package our project as a Linux server. So go back to the Solution Configurations drop-down menu and select Development Editor. Go back to the Solution Platforms drop-down menu and select Win64. And then right-click your project and select Build. And once your project has finished building, go back to File Explorer and open up your project in the Unreal Engine editor. And once your project is open in Unreal Engine, before we package the project as a Linux server build, let's just make some very minor optimization modifications to the project. These steps aren't really necessary, but I want to try to slightly reduce the size of the Linux server build, since in the last part of the tutorial, I ended up deciding to include debug files in packaged builds, which will make the build size significantly bigger. So the first thing that I want to do is remove unused content in the project. So let's go to the content browser down here. Make sure you have the main content folder selected, and right click the starter content folder and select delete. And then it's going to prompt you delete folder. Just click on delete again. That should open up this window labeled delete assets, and you will notice that there are a lot of assets in this folder, but if you look at the two columns on the right labeled asset referencers and memory references, as I scroll down this list of assets, none of the assets in this folder are referenced by anything else in this project, meaning that everything in this folder is redundant since it is never used but gets packaged with the project anyway. Note that we could have not included any of the starter content when we first made the project as well. At the bottom, it will ask you, are you sure you want to delete these assets? Just click on the delete button. Now that those starter content assets are deleted, the next thing I want to do before packaging is disable plugins that we do not use nor need in this project. So click on where it says edit up here and select plugins. And from here, let's filter the plugins you see to only show the enabled plugins. So on the top right corner, click on this eye icon and select show only enabled. Now you should see the enabled plugins for this very simple tutorial project. I know that many of these plugins are not being used right now, so I'm going to show you guys how to go about disabling plugins. I did this already in part 7 of the tutorial by explicitly typing out in the U project file which plugins I wanted to disable, but this time I wanted to show you guys how to do it in the Unreal Engine editor. Basically, if you want to disable a plugin, just click the check mark by where it says enabled, and then once you have disabled all the plugins that you don't think you need, you have to restart the editor to actually apply those changes. But I'm going to keep all the default enabled plugins enabled in this tutorial, so I'm going to click this box again. And I also want to go back to Visual Studio, open up the U project file, and remove these lines of code from the bottom of the U project file. that disable a couple of VR plugins that are enabled by default that we typed in part 7 of the tutorial. After removing these lines of code, saving the file, and restarting the editor, those plugins will be enabled again. Now, I want to remove those lines of code due to the fact that a lot of people use the tutorial project to build their own games, so I want to keep as much of the default settings as possible in order to not interfere with people building their own games, because GameLift and all the code and assets from this tutorial project can be used with things that are not covered in this tutorial series. For example, VR, iOS, Android, online subsystem, and more. Now, of course, you don't have to do what I just did, and you can keep the VR plugins disabled if you are not using VR. But the whole point of me saying all of this is that I want to encourage you guys on your own, going back to the Unreal Engine editor, specifically the plugins menu, to browse through all of your enabled plugins and ask yourselves for each one, am I really using this? Since there will most likely be plugins enabled that you do not use, which ends up unnecessarily increasing the size of your packaged builds. So take some time to look over your plugins, disable the ones that your project doesn't use, and don't forget to restart the editor if you do end up disabling or enabling some plugins. So I'm going to close out this plugins window and this project and reopen the project. By the way, clicking the restart now button that shows up when you modify the plugins through the editor works as well. And once the project reopens, let's finally package a Linux server build. In order to do so, go up to the top left corner here, click on File, select Package Project, hover over Build Target and make sure your server target is selected. If not, then select it, then go back to File, Package Project, and hover over Build Configuration and make sure the configuration of your choice is selected. If not, then selected. Now for this tutorial, I preferably like to use development for testing and debug purposes. And then once you have your configuration of preference selected, go back to File, Package, Project, and hover over Linux, and then go ahead and select the plain Linux option. And then you're going to be prompted with where you want to package your Linux project to. I'm just going to choose the project directory, so if you're okay with that, or once you find the location that you want to package your project to, just go ahead and click on select folder, and that should start the packaging process. And if you want to see the logs from the packaging, just click on the show output log button down here. Once the packaging is finished, we now only have one more thing to do before uploading this Linux server build to GameLift, and that is to create a shell script similarly to how we created a batch script for the Windows server build. So let's restart the Ubuntu terminal. If you still have it open, close it. Let's open it up again. And let me just maximize the screen so that you guys can better see here. First thing we need to do is cd into the location of the Linux server build. So go to File Explorer, specifically where your Unreal Engine project is, and you should see a new folder called Linux Server, and that's where the Linux server build is located. So open up that folder and then copy this path up here in File Explorer, and then go back to Ubuntu. And remember, we have to convert the path we just copied to a Linux readable path. So let's use the wslpath command, type out wslpath and then space in quotes, paste that path we copied by clicking the right mouse button and then press enter. Now let's cd into this location by typing cd space and then in quotes, because this path contains spaces. Copy the value returned from wslpath by highlighting over it with your mouse, press Ctrl C, and then paste by clicking the right mouse button and then press enter. And the root level of the packaged Linux build is where the new shell script will be created. So let's create it and edit it using the Vim text editor inside this Ubuntu command line interface. So type vim, and then space install.sh, the name of the file that we want to create, and press enter. And that will take us to the Vim text editor where we can edit install.sh. Now to actually start modifying the contents of this new file, click the I key on your keyboard to enter insert mode. Notice at the very bottom of the terminal, you now see insert in all caps. Now we can actually start adding and deleting characters to and from this file. And I just want to note before we do start typing in this file that unlike the install.bat script that we wrote for the Windows Server build, this install.sh script can serve a similar purpose of installing dependencies and prerequisite files needed for an Unreal Engine game to run on a new machine. But what I have found with Linux EC2 instances, unlike Windows EC2 instances, is that I have not needed to install new files or programs on a Linux EC2 instance for a very plain and bare bones project. But I have needed to give permission for the server executable file to be executed. So that's all we are going to do in this file. But first, let's note that this is indeed a shell script by typing hashtag !bin//sh. And then on the next line, so press enter, let's change the permission of the server executable in the binaries folder in our packaged server build by typing sudo and then chmod, that's the command to change permissions, and then +x, that's the scope of permissions we want to change it to, and then in quotes, type out the path of the server executable file relative to your project. And remember, not the one in the root level of your package build, but the one in the binaries folder. So in my case, it's going to be dot to signify the current directory / GameLiftTutorial, which, so for you, it would be the name of the project, and then /binaries /Linux, since this is a Linux build, / the name of your server executable, which in my case will be GameLiftTutorial server. Unless you did something special, the name of the executable is usually the name of your project and then the word server appended to the end of it. By the way, you can always verify the path of this executable in File Explorer. For example, in the directory of the package Linux build, I can open up the GameLiftTutorial folder, then the binaries folder, then the Linux folder, and you can see that the GameLiftTutorial server file, as well as the debug and sim files, if you chose to include debug files, are also there. But going back to Ubuntu, once you are finished typing this out, don't worry if you missed anything, there will be a link in the description below to what we just typed out for this install.sh script. So let's go ahead and save this file and quit out of Vim by pressing the escape key to get out of insert mode, and then type :x and press enter. And you can verify that the install.sh script was created by going back to File Explorer, specifically the top level of the directory of the Linux server build, and you should now see a file called install, and it is of type shell script. But with all of that said, we now have everything we need to upload the server build to GameLift, so let's actually upload the build through Ubuntu. So this will require a few things. First, we have to install the AWS CLI on Ubuntu, so go back to Ubuntu and type sudo apt install AWS CLI with no spaces and press enter. And of course, just enter your password if it prompts you for it and press enter again. And it'll prompt you, do you want to continue? Just type in Y, case insensitive, and press enter again. Okay, once that is done, let's clear the terminal, and hopefully you still have access to those access and secret access keys from when we first configured the AWS CLI for our Windows command prompt all the way back in part 3 of the tutorial. If not, that's okay. Just make a new user with the Amazon GameLift full access policy you created back in part 3 as well. If you are not sure how to go about that, we will have a link in the description below to part 3 along with the timestamp range in which we create a new user and as a result obtain a pair of access and secret access keys. Once you have those keys on hand, let's go ahead and configure our AWS CLI so that we can run AWS commands through the Ubuntu command line. Type out AWS configure, press enter, and then it's going to prompt you for a few things. The first one will be the access key, so go ahead, again, if you have the access key, just go ahead and paste it in there. And then the same thing with the secret access key, just put that in there as well. And then for the default region name, just again, choose a region that you're operating in. For me, it's always been US-East-1. And once you've typed that out and press enter for the default output format, I personally prefer JSON, so I'm going to type in JSON and press enter, and that should be it. Your AWS CLI should now be configured. Now we can upload our server build to GameLift using the GameLift upload build command. So type out AWS GameLift upload-build, and then this command will take a few parameters. The first one will be --name, and the value for this can be anything. So I'm just going to keep using GameLiftTutorial. And the next parameter is --build-version, and last time we used 1.0.2, so this time I'm going to use 1.0.3, but the value could have been anything. The next parameter is going to be --build-root. Now I'm going to enclose the value for this parameter in quotes, because I know that the path of my package Linux server build contains spaces. If it doesn't contain spaces, then you probably don't need quotes, but I do. Now the path once again has to be a Linux readable path, so what I'm going to do is open up another instance of Ubuntu, and I'm going to run the wslpath command and then pass in quotes, going back to File Explorer. I'm going to copy the path of the Linux server directory in our local project directory, go back to the Ubuntu terminal that I just opened up, paste the path, and press enter. Now copy this new path returned from wslpath, go back to the Ubuntu terminal where we were typing out the AWS GameLift upload build command, paste the path in that pair of quotes, and let's move on. The next parameter is --operating-system, and the value for this one has to be Amazon_Linux in all cap, because this is a Linux server. And the last parameter is --region, and then the value for this is going to be the code of the region that you are operating in. For me, it's US-East-1. And then once you have all of that typed out, go ahead and press enter. Once the server build has been uploaded to GameLift, go to the GameLift dashboard in the web browser of your choice, and you should now see underneath where it says builds at the bottom the build that you just uploaded, which for me is version 1.0.3. And if you click on the name of the build, it'll take you to this page giving you details about the build. You'll notice that the operating system is now Amazon Linux instead of Windows. Now let's create a fleet for this build by clicking on where it says actions and selecting create fleet from build. And that will take you to this create fleet page. Starting with the name of the fleet, we can name it anything, but I'm going to follow a specific naming convention that I have been using throughout the tutorial, and it will be in the description below, which is starting with the build name. So in my case, it's going to be GameLiftTutorial, and then space the type of instance being used in this fleet. So in our case, it's going to be C5.large because that is the free tier eligible instance type, and then space operating system. So this is a Linux server build, so we're going to type out Linux, and then space the type of the fleet. So in previous videos, we've used spot fleets primarily, but I'm going to actually make this an on-demand fleet, and I'll get to why I want to do that very shortly. And then space the word fleet, and then space the version of this build, which in my case is 1.0.3. And then moving on to the fleet type, we are actually going to keep it as on demand. Now, the reason for this is that in previous parts of the tutorial, I honestly forgot that the free 125 hours of C5.large instance usage per month for the first year of opening up your AWS account that comes with the free tier for Amazon GameLift only applies to on-demand fleets, not spot fleets. So I apologize ahead of time if you have been getting charged. Again, I honestly forgot. However, be mindful of your free tier hours. Make sure that you scale down your fleet to 0 instances when you are not using the fleet or testing your game. Set up billing alerts for your free tier usage through the billing dashboard, and constantly monitor your free tier usage. We will have a nice link to a dashboard in the description below that keeps track of how much you have left for the free tier for all the AWS services that you are using. Because even when your instance is running but not hosting game sessions, that counts as time towards your free tier hours and hours in general when you are getting charged for GameLift. When the free tier is over, meaning that you've reached the 125 hours of C5.large instance usage for GameLift for on-demand fleets for the month, whether it's Windows or Linux, the cheapest way to use GameLift when you have to pay is using a spot fleet for a Linux server build. So I would still heavily advise creating a spot fleet for your Linux server builds when you want to keep testing your game outside of the free tier hour limit, or when you have an actual production game with a lot of player traffic and those instances in your fleet are actively hosting game sessions in order to save money when you have to start paying money to use GameLift for periods of time longer than 125 hours per month in your AWS account's first year. Also, keep in mind you can only use spot fleets if you handle players getting into a game through a queue. In our case, we use FlexMatch for matchmaking, which has to use a queue. So since we already did the hard work, we have the luxury of being able to choose between on-demand and spot fleets for our Unreal Engine game server. Moving on, let's scroll down, leave the other settings set to their default values and go to the process management section, specifically the server process allocation section, and let's define the server processes that each server process in our fleet will run. You will notice for this default entry in this table, the fixed prepended value in the launch path is different than the one for server processes in a fleet. For a Windows server build, instead of c:/, it's now /local/, and instead of backslashes, there are /. So let's go back to File Explorer and go to where the server executable is located, the one in the binaries folder. So from the package Linux directory, go to the GameLiftTutorial folder in my case, then go to binaries, then go to Linux, and copy the path in File Explorer up to but not including the Linux server directory. Go back to the GameLift console, paste it in for the launch path for this default server process, but replace the backslashes with /. So let me just do that real quick. And then let's add a / here at the end and write the name of your server executable, which in my case is GameLiftTutorial server. And then for the launch parameters, it's going to be exactly the same as the ones that we defined for server processes in a fleet for Windows server build. So let's type out in this next box -port = 7777 because we explicitly defined through the command arguments which port a server process will run on, and then space -password = dummy because our server process at the end of a game session's lifespan, at the end of a match, the server will call an API method that sets match results, and we obviously want that API method to be password protected. So in previous parts of the tutorial, we made that quote-unquote password value dummy. You can make it anything, but if you change it here, then you have to change it back there where we set it in our Lambda authorizer as well. And for the concurrent processes, just leave that value defaulted to 1 because we only want one server process listening on one port at a time. Then let's define some more server processes to run on each instance of this fleet simultaneously. You can have up to a total of 50 processes per instance, but I'm just going to add 4 more for a total of 5 per instance. So click the Add Configuration button 4 times. And the launch path will be the same for each of them, so copy the value from the first row and paste it for each of the rows below. And then the launch parameters for each of these new server processes will be almost exactly the same as those for the first one. We just have to make sure the port number for each process is different from each other, so copy the launch parameters from the first process and paste them for the processes below. Then let's change the port number for all of them so that each process is assigned a unique port number. So for the second one, I'm just going to change it from 7777 to 7778. And then for this third one, instead of 7777, we're going to make it 7779. And then instead of 7777 for the fourth one, we're going to make it 7780. And then for the last one, we're going to change the number to 7781. And then for the concurrent processes values, we're going to keep them all at 1. And then let's save our changes by clicking the green check mark by each server process configuration. And the last thing that we have to do before creating this fleet is configure the EC2 port settings. So go down here to where it says EC2 port settings and click this add port settings button to add an entry to this table. And in this row, we are going to specify the port range that we want to open up for incoming connections in each instance in this fleet. So since we specified port 7777 to 7781 in the server processes above, let's write here 7777-7781. And for the protocol, change that from TCP to UDP, and for the IP address range, type out 0.0.0.0/0 so that anyone can connect to the server on the ports in the port range, and save your changes by clicking the green checkmark button. And I kind of glossed over it, but keep the default settings for the game session activation and protection policy sections. Once you're done with everything though, go ahead and create the fleet by clicking the initialize fleet button. And once your fleet has been created, you have to wait some time for the fleet to activate. For me, this generally takes about 15 minutes, so go ahead and pause the video and come back. If you want to check on the latest status of your fleet, you can check the events tab and periodically click the refresh button. But if you want the other parts of the UI to change, such as in this row, the status, the number of active instances, and the number of active servers, then you have to refresh the page. Once the latest event in this events table after refreshing the page is of code fleet scaling event, and the status of the fleet after refreshing the page is active, and there's one instance with at least one active server depending on how many you define in the fleet configuration, we are now ready to test our game. But before we spin up some clients, we have to replace the fleet destination in the queue attached to the matchmaking configuration that we have been using throughout almost this whole tutorial, so that the clients can connect to this new Linux fleet that we just made. So go up here to where it says fleets, click on it and select queues, and then select the name of the queue that is attached to your matchmaking configuration. In my case, it's GameLiftTutorial queue, so I'm going to click on that and then select the actions menu and click on edit queue. From here, go down to the destination section, and to the right of the only entry in the destinations table, click the pencil icon to edit the destination. And then for the value under the fleet or alias name column, just go ahead and click on that drop down menu, and from this menu find the new fleet that we just made. And it should be easy to find because by all of these fleet IDs, you should see in parentheses the name of your fleet. So in our case, it's going to be the GameLiftTutorial C5.large Linux on demand fleet, so I'm going to select that. And then to save your changes, go ahead and click the green checkmark button, and then click the submit button to save your changes to the queue. Also, in case you guys haven't done so yet, because I forgot to explicitly do this in the last part of the tutorial, even though we changed the queue destination to no longer use the old Windows fleet, we should always scale down a fleet's capacity to 0 active instances when we know that we are not going to use it, in order to not get charged for instance usage. Because remember, there doesn't have to be any game sessions on an instance for it to be in use in the eyes of AWS billing. So let's go to where it says queue up here, click it, and select fleets from the drop down menu. Then click on the last Windows fleet that we made in this tutorial. For me, it's going to be the GameLiftTutorial C5.large Windows Spot Fleet 1.0.2. And then from here, go to the scaling tab and then scroll down to the auto scaling policies section, and by where it says manually adjust the desired instance count to, right now I have it at 1 because I didn't turn down or scale down the fleet capacity in the last part of the tutorial. I did leave a comment down suggesting to you guys that you should. So if this number says 0, and if we scroll up and there's 0 active instances with 0 active servers, then great. But if not, and this number says 1, then change it to 0. And to save your changes, go ahead and click the check mark. And once again, if it already said 0, then you don't even have to do this step. Then go to the events tab and then click on the refresh button, and you should see the latest event is of code fleet scaling event, and the desired size is 0. So just wait, I guess maybe I think a few minutes keep refreshing the page until the number of active instances is 0, as well as the number of active servers is also 0. Okay, after waiting some time, refreshing the page, and seeing that both the number of active instances and active servers are both 0, let's finally test the new Linux fleet. So go to your project in File Explorer, go to where your Windows client is packaged, which for me is in the Windows No Editor folder, so open that up. Now before I launch multiple instances of the client, I want to mention that I've noticed that many people have experienced a common issue when their clients try to join the server. The issue is that different players on different clients click the join game button, they get into a match successfully, a game session is made for that match on a server process in your fleet, and the players try to connect to the server, but they immediately get rejected from the server. Then you go to check your client logs and see an error on the lines of client connection rejected due to a project or code version mismatch. Now, I do not have to repackage the client, and you shouldn't have to either if you have been strictly following the tutorial, because the only changes to the server that we technically made since the last time we packaged the server build was removing unused starter content assets, which don't affect either the server or the client, and disabling or enabling plugins. Now, I recommended you guys to disable unused plugins, so that should not affect anything, and I technically re-enabled a couple of default enabled VR plugins. However, there were no assets or code added that utilized those plugins on the client or server. So all in all, for me, I do not have to repackage the client. For those who are not strictly following the tutorial series, if you have made some kind of code or content change to the project in between the last time that you last packaged the client and last packaged the server that will affect the client in any way, or are even unsure if you made that sort of change, because many times people either forget or modified parts of the project that are common to both the client and the server without even realizing. Then pause the video and repackage your client so that it is up to date. Once you are all set, let's go ahead and launch 4 instances of the client. Once you have 4 clients opened up, go ahead and log into an account on each client using either Google or Cognito sign-in. Please make sure that you are using a unique player account on each client. And once you have signed into 4 separate accounts, try joining a game with only 2 of the clients, because I want to make sure all of the server features from a force such as backfill are still working. Once those 2 clients are in a match, let's try joining a game with the other 2 clients, and hopefully the backfill kicks in and all 4 players end up in the same game, in the same match. In my case, I got really lucky and all 4 players are now in the same match. Now keep in mind that the rule set behind the matchmaker won't always prefer backfilling a match with players. It may sometimes prefer starting a new match with those players. So if you can't get the backfill to work right away, just keep trying to confirm that everything is still working as normal, which in this case does seem to be the case. Another cool thing that I want to point out that you may have already noticed is that we were able to connect to a Linux server with Windows clients. This can be a small introduction into cross-platform development, although technically you could argue you already got an introduction before, because the Windows EC2 instances are running a version of Windows from 2012, which isn't the same operating system that your computer is running on, assuming that you are using Windows 10. But it's quite interesting because this concept can be extended to a multitude of platforms. For example, mobile build clients, whether Android or iOS, should be able to connect to the server. Even console-based clients like Nintendo, Xbox, PlayStation, and others should also be able to connect to this Linux server. And since we only used Unreal Engine native code throughout this tutorial series, this project is very portable to those other platforms that I just mentioned, because the only part of this project that isn't native to Unreal Engine is the GameLift server SDK, but that only applies to the server, not the clients. And since we are using GameLift, we only care about building the server for the Windows and Linux platforms. While this game is going on, I actually want to check the GameLift console to make sure that a new game session started in the Linux fleet we just made. So I'm just going to press Alt-Enter so I can go back to the web browser, and then let's go to the general fleets page, and then from here let's select the latest fleet that we just made. Go to the game sessions tab, and you should see 1 active game session. Now if we click on the ID of that game session, we should see 4 active player sessions, because we do indeed have for players in the game. And then let's go back to the clients and let's just wait until this game is over so that we can see which team won the game, and then we can verify the match results on DynamoDB. Okay, so in my case it looks like the aliens won and the Cowboys lost, and as normal the clients get kicked out of the match. So let's go to the DynamoDB dashboard in the web browser of our choice so that we can verify what we just saw. So go to the table section, and then let's start first with the players table. Since that's the easiest, let's just match the number of wins and losses that each player has to what we see on each client. So if we go to the items tab here, kind of just get a general feel of how many wins and losses there are, and then let's compare that with the wins and losses we see on each of these clients, and I think we can all generally get a feel that the numbers do look right. They coincide pretty much exactly with DynamoDB. Alright, now let's just quickly check the match results table, and let's filter the items by the ID of the game session that hosted the match that we were just in. So go back to the GameLift console and copy the game session ID up here, go back to DynamoDB, click on this add filter button. For the attribute, type in ID, case sensitive, and then for the value just paste in that game session ID and click on the start search button. You should get only one entry because there should only be one result for a match. Go ahead and click on the ID value and that'll give you the entire item. Expand the losing and winning team, as well as the players in each of the winning team and losing team. And you'll notice that the winning team was the aliens and the losing team was the Cowboys. And that's kind of all. That's as far as I'm going to go in terms of verifying the match result, because I'm sure it's good to check these skills, make sure that they're right. But I mean, they seem pretty logical to me. If you do the math, the teams are somewhat even, so we'll just leave it at that. And if we go back to the GameLift dashboard, now I went back to the general fleet page that lists out all of your fleets, but just go back to the Linux on demand fleet. And now if you're on the game sessions tab, you should notice that the game session is now terminated. And if we click on the game session to look at the player sessions inside, all the player sessions inside of there are completed. But the fact that this game session is now terminated means that this server process running on this port 7778, is now free again to host another game session. And I know that there are more features to test, but I'm going to leave that to you guys watching. For now, we are going to move on to remotely connecting, aka SSHing, into a Linux EC2 instance in our fleet on GameLift running our game server. And so let's quit out of all of our Unreal Engine clients, as well as Unreal Engine itself with our project open, and let's start a new instance of the Ubuntu terminal. The steps that we need to take to remotely connect to a Linux EC2 instance are very similar to those that we took in the last part of the tutorial to remotely connect to a Windows EC2 instance. And the reasons for remotely accessing an instance are still the same. It's useful for troubleshooting fleet activation issues and monitoring game server activity in real time by looking at logs and running benchmark tools. The first thing that we are going to do is cd into a folder that we can trust for holding credentials used to connect to the Linux server. This can be any folder that you want, but I'm going to choose my local machine's documents folder. And once you have that path, convert it to a Linux readable path by running the wslpath command and then passing quotes the path of that folder. Again, it can be any folder. For example, I'm going to type out the path of my documents folder. And once you have that all typed out, go ahead and press enter. And then let's cd into the folder by typing cd and then in quotes, which is only needed if your path has spaces in it. Copy the path returned from wslpath and paste it here and then press enter. Now, just like when we remotely connected to a Windows EC2 instance, we have to get credentials for accessing a Linux EC2 instance. And to do that, we have to run the GameLift get instance access command, but that command requires the ID of the instance that we want access to. And in order to get that instance ID, we have to run the GameLift describe instances command to get information about all the instances currently running in our fleet. So type out aws GameLift describe -instances and then --fleet-id space, then go back to the GameLift dashboard, go back to the fleets page, go to the Linux fleet and copy the ID fleet value, go back to Ubuntu, paste that value and press enter. Once that command is done running, you should see an array of instance objects. In my case, there's only one instance running in our fleet. Therefore, the array returned only has one object, so I will be remotely accessing this instance. So let's get the credentials needed to connect by typing aws GameLift get -instance-access and -fleet-id space. Hopefully you still have that fleet ID copied to your clipboard. If not, then recopy it, and once it's copied, paste it. Then type --instance-id space and take the instance ID from one of the objects in the instances array returned from the scribe instances, copy it, and then paste it. And unlike the last video when we ran this exact same command, we have to add a couple more parameters. So type out --query and then space in quotes InstanceAccess.Credentials.Secret and then --output space text. And what these two new parameters will do is parse out from the return object or the return output the secret value in the credentials object in the instance access object and output that value as text. But the last thing we need to do for this command is take that output and store it in a PEM file, which is basically a file that is encoded in a specific format normally used for storing cryptographic keys and certificates. So to do that, type out the greater than sign, and you can name this anything you want, but I'm going to name it GameLift tutorial key, and then make sure no matter what the name of your file is that it ends with .pem. And once you have all that typed out, go ahead and press enter. Then after that PEM file is created, I saw in the GameLift documentation that they recommended setting permissions on this PEM file to make it read only in order to prevent accidentally overwriting it, deleting it, renaming it, or moving it. So this next command that I'm about to run is not necessary, but I'm going to run it anyway. So if you are interested, type out chmod 400 and then the name of your PEM file, which in my case is GameLift tutorial key.pem, and press enter. Note that these permissions are only set in the Ubuntu environment, so you can still theoretically modify and delete this file in the Windows environment. Next up, we have to update the fleet settings in which this instance is a part of to allow inbound connection access to port 22 on instances in this fleet. When we did this for Windows, the port was 3389. The reason is that on Windows machines, port 3389 is designated for Remote Desktop Protocol, which provides a graphical interface to users connecting to another computer over a network connection. On the other hand, when connecting to a Linux server, normally one would use what is called Secure Shell, also known as SSH, which provides a secure way for a client machine to connect to a server machine over an unsecure network connection via a cryptographic network protocol. And the standard TCP port for SSH is port 22. That's also why, unlike the last video, we took specific output from the get instance access command and stored it in a PEM file, because last time when we ran that command, we got back a username and password, which is used to connect to another Windows machine through Remote Desktop Protocol. To connect to a Linux EC2 instance using SSH, a username and a private key are needed, so instead of passing a password to log in, authentication is done using some kind of public key cryptography or asymmetric cryptography algorithm. With all that said, let's actually update the fleet settings now to open up port 22 on instances in that fleet. So type out aws GameLift update-fleet-port-settings and then -fleet-id space, and then take the fleet ID from up here from describe instances, or really anywhere on here, and then copy it and then paste it. and then type --inbound-permission-authorizations, and then quotes, since we want to open up port 22, type FromPort equal 22, comma ToPort equal 22. And then let's open port 22 to our local machine, so type out comma IpRange equals. Now if you wanted to open this port to any machine, you could type here 0.0.0.0/0, but I would only recommend opening this port to your computer only. So like the last video, get your IP address. I like to get the IP address from wsmyipaddress.com. Link to this will be in the description below. If you do go here, copy your IP address by where it says IPv4, go back to Ubuntu, paste it, then add a /32. That is the /32 subnet mask to denote that this is only this is a IP address only pointing to one machine, and then type comma protocol equal TCP. And once you have all of that typed out, go ahead and press enter. Now everything should be good to go to finally remotely connect to our Linux EC2 instance using SSH. And if you missed any of the commands used in this video, just a quick reminder that they will all be in the description below. With that said, let's run the SSH command to connect to the EC2 instance. So type out sudo, and keep in mind that you will need the sudo keyword here. Otherwise, you will get an error along the lines of permissions for private key are too open, which occurs when the PEM file is accessible by other users on your computer, which is technically a security risk, but not really in my case, considering that I am the only user, Chris, on my local machine. Now, if you are using a computer that is shared by multiple people, then I would consider changing who has access to this PEM file to be only you and no one else. Otherwise, other people on your computer signed in as different users will be able to access that PEM file. To change the access permissions for the file, you would do it in the security settings for the file when you right-click the file in File Explorer and select Properties. We will have more information about this in a Stack Overflow post linked in the description below. But if you are like me, with no one else on your computer but you, then running the SSH command prefixed with the sudo keyword to SSH with root privileges is absolutely fine. So let's resume typing. Write SSH-I and then the name of your PEM file. In my case, it's GameLiftTutorial key.pem, and then type out the username that you're going to remotely connect in as. So it's almost always going to be gl-user-remote, and then add a @, and then copy the IP address of the Linux EC2 instance that you want to connect to. I'm just going to get it from the describe instances command and just paste it here, and then go ahead and press enter. You're going to be prompted with your password. Just go ahead and type it out and press enter again, and you should be SSH'd into your Linux EC2 instance. The first thing that I want to do is actually clear the terminal so that we have more room again. And then let's cd into the directory containing our game. So if you remembered from the fleet settings, the launch path of each server executable in each instance in our fleet was prefixed with /local/game/. So let's first cd into the local folder. So type cd /local and press enter. And from here, let's run the ls command to list out all the files and directories in the current working directory that we are in. So type out ls and press enter. And the important directories include the game folder, which contains our package server build, the Whitewater folder, which contains files used by the GameLift service to manage game hosting, and those files should never be changed, and the game metadata folder, which contains certificate and key files in the case where the fleet that this instance is in has TLS certificate generation enabled. But for this part of the tutorial, we are only interested in exploring the packaged game build, so let's cd into the game folder. And if we run the ls command here, we can see that this is indeed the same package server build that we upload to GameLift, because it has files and folders from there. For example, the project folder containing the binaries folder where the server executable is located. You may have noticed that the install.sh script is not there, similarly to how the install.bat script isn't in any of the Windows EC2 instances. Don't worry, that's normal. That install script gets executed when the fleet is being activated, but it doesn't get stored in the instances. Moving on, let's cd into the project folder. So in my case, it's called GameLiftTutorial. And if we run ls here, you will notice that there is a binaries folder that I just mentioned, as well as a save folder which contains logs from the running server processes of our game. First, let's check out the binaries folder, so cd into that, and if we ls here, you should see a Linux folder, so cd into there as well, and ls again, and you should see the server executable. It's the GameLiftTutorial server file in my case with no file extension, as well as the debug files for the server, which are in the form of a .debug and a .sim file, unlike the debug files for a Windows Server build, which is in the form of a PDB file. Again, I would highly recommend including debug files with server builds, at least because the server is usually secure and they can make the stack traces in the generated logs easier to read, which helps with debugging errors. Now, the last thing that I want to do in this part of the tutorial is look over the server logs, so let's go back a few directories by running cd space ... a couple of times. And since the logs are in the saved folder, which is in the project folder, which is where we are now, cd into the saved folder and press ls to look at all of the log files. Oh, sorry about that. It's actually in another folder called logs within the save folder within the main project folder. So type out cd logs and then press ls again, and in here you should have all of your log files, which include not only the logs of the currently running server processes, but also the logs of past server processes from up to a certain date. Let's look at the actual content from one of these files by typing vim and then the name of one of these log files. I'll do one of the log files that don't have the word backup in its name because the non-backup log files are usually the latest log files. So the logs of the currently running server processes, not the logs of terminated server processes. So for example, I'm going to choose GameLiftTutorial.log. Once you have one selected and typed out, go ahead and press enter to open the file in the Vim terminal. And I didn't mention this before, but when you enter the Vim terminal, by default you are in what is called normal mode. If you want to edit this file, you would have to change from normal mode to insert mode, like we did earlier in this part of the tutorial when creating the install.sh script. And if you want to leave the Vim terminal, you would have to first return from insert mode back to normal mode before doing so. But since we were just looking at this file, let's stay in normal mode, and when you are in normal mode, you can use the H, J, K, and L keys to navigate the file. The L key is used to move your cursor to the right, while the H key is used to move your cursor to the left. The J key is used to move your cursor down, while the K key is used to move your cursor up. And if we go all the way down by holding down the J key, by the way, you can hold down any of the H, J, K, or L keys to constantly move your cursor in one direction. And I know it's going really fast here, but this is a normal server log. Even though it is the log of a server running on a Linux machine, it looks almost identical to what a log file of a server running on your local Windows machine would look like. And if we scroll all the way down here, we can actually see that the server process, if I just go a few lines up here, and then go to the right, you can actually see that this specific server process, so the log of this specific server process is listing on port 7780. And also you may have noticed that none of the H, J, K, and L keys wrap around. So once you reach the end of a file or the end of a line, it won't go back to the top or bottom of a file, nor will it go to the last or next line. Also, another feature that you guys may find useful, because I know that many people tend to search for specific words in their logs, whether it is for finding the occurrence of a specific word or using a specific word to find the occurrence of a specific line in the log file. You can use the search feature in Vim by pressing the / key while you are still in normal mode, Remember, if you are in insert mode, you would have to press escape to get back to normal mode like we did again when we were writing the install.sh script. But moving on, after you have typed the / key, type the term that you want to search on. So let's say I want to search for 7780. I would recommend typing out the port number that you see on your screen right now. So it may not necessarily be the exact same number that the server process for this log file happens to be running on, but once you have that typed out, press enter and it'll take you to where that port number appeared in the file, and it highlights the term you searched on. Now, of course, the term can appear multiple times in the file, so if you want to navigate the search results, press N to find the next search result in the downwards direction, and press Shift N to find the next search result in the upwards direction. Note that these two commands do wrap around the file, so if you reach the top of the file, or I guess the last search result or the topmost search result in the file, the next time you press Shift N, you will end up at the bottom of the file or at the bottommost search result of the file. And if you reach the bottommost search result of the file or the bottom of the file, the next time you press N, you will end up in the top of the file or the topmost search result of the file. Now keep in mind that the search feature in Vim does not automatically search for exact occurrences of a term. For example, if I did / and then the word port and then press enter, you will notice that after going through some of the search results using the N and Shift N keys, that it counts words that contain the word port, not just exact matches for the word port. If you did want to search for only exact matches of a word, then you want to do / and then / then less than sign, then the term that you want to search for. So let's say the word port again, and then / and then greater than sign, and then press enter. This time, if you go through the search results using the N and Shift N keys, you will notice that it only searched for exact occurrences of the word port. And that's all I'm going to go over for Vim for this tutorial. There's a lot more you can do in Vim that I encourage you guys to check out, but for now, let's quit out of here by typing :Q. Note that this quits the file without saving changes, unlike when we did :X to save our changes to the install.sh file earlier. And again, you have to be in normal mode while doing this. So if you're not in normal mode, you can always press escape to go back to normal mode. But moving on, press enter. And that pretty much concludes what I wanted to go over with regards to remotely connecting to a Linux EC2 instance. So let's now terminate our remote SSH connection by typing exit and pressing enter. Also, before I forget, go back to the GameLift dashboard, specifically the page for the Linux fleet that we created in this part of the tutorial, and let's scale the number of instances in this fleet to 0 if we know that we are not going to be testing this game anytime soon, so that we don't get charged or that our free tier hours don't get used up. So go to the scaling tab and then scroll down to where it says auto scaling policies, and underneath that specifically where it says manually adjust the desired instance count to, for me it says 1 right now, but if it's any number greater than 0, and again if you want to shut your fleet down, get rid of all the active running instances in it, then change this number from whatever it is, if it's not 0, to 0, and then go ahead and click the checkmark button to save your changes. And that will be it for this part of the tutorial. We managed to cross-compile a Linux server, upload that server build to GameLift, create a fleet out of that build, and remotely connect to an EC2 instance in that fleet. So if you enjoyed the video and found it informative, then please like, comment, and subscribe. If you want to support the channel, then please consider becoming a patron on Patreon. Huge shout out to all of our patrons on Patreon, especially our higher tiered patrons, which include Max Norris, Elise, Diego, Eduardo Camacho, BioBlaze Payne, Karan Tatum, Keith Perry, and Solar Tricks. Link to our Patreon along with links to our PayPal, Discord server, and other social medias are in the description below. Go check all of those out, and as usual, have a nice day.